Good morning, everyone. Good morning. Come on, you got up early to do this. So we have an interesting panel. We've got some great experts on the panel to talk about artificial intelligence. And the idea here is that it's a topic that's got a lot of confusion around it. It has to sort of integrate into our current systems. And so what's sort of the reality versus the hype? And so I'm with the Florida Institute of Technology. This is my Center for Advanced Manufacturing and Innovative Design in Palm Bay, Florida. I get a lot of visitors in the winter, as you might imagine. And so our focus is basically sort of pushing the envelope in terms of this integration between engineering, manufacturing, and into the support, so product lifecycle management piece. The focus of this is sort of given the advancements in computing technology, the idea of AI has really resonated across the board, but especially sort of at the higher levels, there's a lot of confusion and misunderstanding and even trepidation about how this is going to impact our organizations. And so, if I could get the next slide. I wanted to kind of show that this is the AI landscape, and this is taken from a book called Life 3.0. And it's sort of literally a landscape of sort of the rising waters of AI that are covering various areas. And this is the Moravec paradox, and the idea is the fact that the simpler things that we do, sensor motor stuff, are highly compute intensive and difficult, while some of the more intellectual things we do are basically less compute oriented. So there's a wide range of kind of concerns and focus in terms of what's going to happen. So you have at one end of the spectrum Elon Musk and Stephen Hawking thinking that this is the end of civilization. There are others, myself included, that think that with the advancements in computer technology, we'll be able to have everything in terms of simulating the physical world except human intelligence, because human intelligence is very different. So those that are concerned about Skynet and the Terminator are sort of at one end of the spectrum, and those of us that think that this is a really good capability to add to our tool chest and be able to get great ability to take wasted resources out of it. And so the old joke is faster, better, cheaper, pick two of them. This is really an ability, I think, to pick all three. And so we're certainly seeing AI kind of pick up into other areas, but what is realistic and what should we be looking at, as executives and people in the industry in terms of actually integrating that into our organizations, and who's going to do that and who are going to make those decisions. So with that, I'd like to bring on our esteemed panel, Bissell Smith from Northrop Grumman, Bala Chambordi from Boeing, and Nitesh Bansal from Infosys, and Avner, who you saw before. So guys, come on up. And what we're going to do is sort of set the stage with brief presentations from our panel, and then move into the Q&A. And you saw the way to ask questions is on the app that we have. So look at the app, vote for the questions that you think are interesting, and then we'll take it from there. So with that, I'll turn it over to Bissell to start off and get us going in terms of this great topic.
Well, thank you, everybody. Welcome. So I'm with Northrop Grumman. I'm going to kind of put what I would call a practical approach to this. My background has been running mostly in the functional area, but managing large IT activities for a very long period of time. I've been with the company for almost 33 years. Our advancement is here. There we go. So one of the initiatives that we're spending a lot of money on today is really around what we call the Northrop Grumman integrated digital environment. And that NGUIDE term is something that we're branding internally. Every large aerospace company has their own internal branding for basically the exact same initiative with different variations of it. But this really lays out what I would call the opportunity space to apply new information technology along with embedded AI capabilities in it. It's whether you're in the design phase of things and looking for aids to help in that arena, the manufacturing and ways in order to improve the automation and quality of what it is we're producing, sustainment area in order to improve really what boils down to is the profitability by making a lot of really smart decisions with very complicated field of activities that are going on in the maintenance area. It's everything from parts management and the logistics associated with that all the way down to using information to predict longer life cycles of the product. And then in the integration area, customer integration area. Internally, no different than Boeing, Raytheon. I was just in a forum with a lot of these guys yesterday in Dallas. We're all working on different components of the same thing where we're trying to link together our environment, our digital environment, from the design phase and making sure we put quality up front in the design in order to create a much more efficient downstream set of activities related to manufacturing and then into the sustainment environment. And it's really through this integration that's going on between the PLM world and the ERP world where we see opportunities where we can embed different capabilities to achieve higher quality, to achieve more efficient use of people's time, to achieve some better automation in the factory areas. So, I threw this chart together to kind of ground the conversation that internally within a company, and I think like any large aerospace company, the OEM side of things, we're dealing with hundreds, if not thousands of applications, but they pretty much boil around two very large architectures, the PLM architecture and the ERP architecture. And no different than the large aerospace companies in our world, that really represents mostly Siemens and SAP. And then with a lot of different applications bolted on and connected to it in order to deliver all the different either back-end office capabilities or manufacturing capabilities or sustainment activity that goes on in the company. So when you look at those different things that are going on in the, I'll call it some of the fuzzy gray lines of what really is AI, I put it in these terms. Data science, which we're all out buying, I should say not buying, hiring a plethora of data scientists today that are, descending within our organizations and finding new ways to work with information and produce insights, because that's really what their job is to work with all that information to produce insights. In the area of machine learning, another area that's very clouded around AI, you're trying to create predictions. As an example, in the sustainment world, where predictions can really help you manage your ROI in like a PBL type contract. And then artificial intelligence, I view it as something that's trying to produce actions. Now, those are simple definitions, but it's an easy way to try to create some segregation between these three areas that are often intermixed. We were talking earlier this morning about that and how these things kind of intertwine, and there's really kind of a gray, fuzzy line between all of that. So what are we really after? We're after improved efficiencies, and I should have put quality there because it's efficiencies and quality. We want to get more out of our analytics and making use of the data that we have. And we're trying to get our employees into a situation where they can get a much better experience. Aerospace and defense world is excessively complicated. I used to be in the financial services world, and it was, quite frankly, very simple compared to the aerospace world. So, expectations, because these are the areas that I think in the short run where we're going to see some opportunities. And the IoT analysis and the data processing, I can see where AI can help a lot around capacity management and getting a better sense situationally of what's going on in a particular work cell or factory area in order to provide a better way to improve efficiency and make better use of our assets and our people. Predictive maintenance, I think that I don't have to sit here and talk about that for the next hour. You guys already have a sense of that. If you're in the aerospace and defense business, of where there are benefits associated with predictive maintenance and location analysis. We are building product now across a much larger map and area than we ever used to 30 years ago when I entered this business, and with a much larger supply chain. And so that awareness situationally of where things are occurring and the automation that can come along with improving our decision making around that is relatively important. Automation, providing a sense of awareness of our surroundings. So what do I mean by that? So in our advanced manufacturing team, they'd like our automated machinery to be a lot more situationally aware of what's around it. It's programmed to perform a repetitive task, but yet it knows not what is around it. And so anywhere where we can put some capabilities in the machinery where it's sensing workers that are nearby, someone inadvertently putting another asset next to it that it could end up knocking over, that kind of helpful understanding through AI technology that you can do that. No different than what they're doing, with some of the automated vehicles. So sensing collisions, and I believe there's a huge opportunity space in FOD. I can't tell you how many meetings I still dial into today where we're chasing FOD issues that, no matter how good your procedures and how good your training is of your employees, they're still leaving material behind. And so tools that can go out and optically sense and look for things that shouldn't be there and help the factory worker identify that before it gets too far down the process and unfortunately into delivery would be helpful. Inspection. Quite frankly, AI, I believe, has a great opportunity in the manufacturing process around the inspection area and doing real-time inspection in the automation process, and then dealing and making actions associated with that learning. Material handling, I read about this all the time. I don't know, after that last Uber experience in Phoenix, I'm not so sure we want to do this just yet, but maybe with advanced handling of capabilities and interacting with employees, I see a good opportunity space there in the future. So decision analysis. I'll just highlight an area that I have been passionate about for years: complex application support and enhancing cognitive performance. Procurement. Supply chain management is probably one of the most complex things we do. I mean, we like to talk about the complexities of manufacturing, but if you've ever seen what an employee, a poor buyer, or a major subcontract manager has to contend with, and especially if you introduce the international environment to them, the decision making that they have to go through in order to build up just the basic contract to release out is enormous. The decision tree would boggle your mind associated with it. And so there's no doubt there's a lot of errors in the process. If you go look inside our company, when you go look at data quality, some of the areas that are the most dirty with respect to the integrity of data are in the supply chain area. And so I believe that embedded AI capabilities in the application can go a long way in helping people make the right decisions very quickly and speed up the process in order to get a contract out the door. Not seen anybody to develop that yet, but I think the opportunity space is huge in that area. Planning and analysis, clearly taking all those disparate components of information together and doing a much better job of helping in the planning area, I see. Risks. I understand I wasn't here yesterday. I was out in a different discussion in Dallas, but someone brought up cybersecurity, and quite frankly, I think the areas are ripe for error issues in that area as we bring in all this technology into the company. But it can really help in the area of investigating attacks and help in the area of fraud analysis with our activities that our employees are doing because of relating all this information together in a smarter way. And so without going through all these, because you can talk about each one of these things in a very, very independent and long discussion, these are the areas that I see in the near term at Northrop Grumman where we are looking for opportunities down this space. Really want to spend time talking about what the impediments are, because I think we have to overcome these if we're ever going to take this technology into our environment and make good use out of it, especially from providing a return. So one's just the pure maturity of the capabilities. This is a relatively, in a lot of areas, immature area. So it's really important that you've got teams of people that are looking at the technical readiness of these capabilities and really not deploying them faster than you should. Because all that does is increase cost and increase inefficiencies and can create a bit of havoc inside your company. So you don't want to chase these things too early. We kind of pride ourselves at Northrop of being kind of a little bit late adopters, and a lot of things we do for this reason. We love it when Lockheed and Boeing go out there and spend billions of dollars on some of these things, and then we just come around and pick them up later for a lot less money. SAP and Siemens, we're looking for them to embed these capabilities. And I can speak from, I was meeting with SAP yesterday. They have their Leonardo, they're calling it Leonardo. It's kind of a cool little name, but they're building capabilities around AI and making call outs with different APIs into the different applications. And we'll have to watch and see that mature. It's very immature right now. I wouldn't make any claims. I think if there was an SAP executive here, he'd probably tell me it's a lot farther along than they say, but I don't think it is. But it's promising. And I talked to Siemens a week ago and asked them, send me all the things you're doing in the AI area and embedding technologies. They're both growing these areas slowly, but I think that we're going to find a lot of opportunity. Data quality. I don't have to tell you guys, data quality in our companies suffers significantly, and you've got to put tools up front in the process. We use a tool called Information Steward that goes out, and as the transactions are occurring, it's trying to discover the data quality errors in the upfront transactional process. You've got to put capabilities in place like that, because you cannot harness it for predictive analytics. You can't harness it for improving efficiencies in your process without having good quality of your data to rely upon. Capital funding, although I recognize you talked about the ROI isn't the issue, I would contend the ROI is still always going to be the issue, because you always got to go in front of a CFO and you got to explain to them why you're going to spend tens of millions of dollars. And although I do think that there is a quick connection to return, it's still not something that's understood by many of the people you have to get approval through. So AI strategies across the architecture, that's going to be tougher, because none of these guys like to ever talk to each other, the vendors that create all these tools that link together. The lack of staff and skills. If I had to create a number one issue, and I should have put that on the very top of the chart, especially in the factory area, we were talking about earlier this morning, our employees, this is not an area where you go learn on the job. You're going to have to hire the experts up front. They're going to have to understand what it is that they're actually installing, the inner workings and the math and the logic associated with it. If they don't understand it, then there is going to be way too much learning after deployment. And that's going to create nothing but variations and higher cost and higher deployment activities. So we're going to have to make sure we get the smarts of the people inside as we start deploying some of these much more sophisticated techniques. And today we're all hiring data scientists, and I can tell you it's creating chaos. Because you get all these really smart people that don't understand our business all playing with data and doing things that I'm not so sure is creating a lot of return just yet, until we really teach them about the business and where to really apply it. And then security and privacy concerns, I think, go without question, but the more automation that we have and the more interconnected our architecture becomes, the higher the opportunities are for data mining that from the outside. So I put in a little Gartner chart down below that kind of says where people are in AI today in most of the major companies, and I put a red line where I think Northrop is as a company. And I challenge you guys to look at this chart and decide, where are you? Are you of no interest in the 14% category? By the way, that doesn't add up to 100%. I don't know what, maybe I didn't read far enough into the little Gartner chart to figure out where the rest of it went, but, or, is it on your radar? I would tend to think it's on all of our radar, and especially you guys wouldn't be sitting here if it wasn't. Is it in any of your mid and long-term plans yet? And in what way? Or is it in a short-term plan, which means you're really moving out on it? Or have you already invested in it, and are you using it today? And so I would say that we have very little usage of it today in our company, and it is definitely on the radar screen, and we're looking at it. But again, we have a tendency in our company and our culture to be a little bit late adopters in these areas because we want to make sure that we spend our money wisely. With that, that's it.
Thanks, Bissell. Paula?
Maybe I'll just start off saying, I used to be an AI researcher back in the late 90s. That was the point in time where it was just starting to get safe to say you were an AI researcher. So we had this whole AI winter, and that was the point. It was just starting to get safe to say you were an AI researcher. So I'll start off with that. So I work in Boeing. I lead the cybersecurity and networking R&D organization. And I thought I'd give you a little bit of a background, an overview of the different technical areas within AI, and then different applications, and then conclude with what Boeing is doing. So at a high level, if you think of AI, a good way to probably define it is to say that machines that act like humans, don't think like humans, we're some ways off before you get there, but machines act like humans, and basically rational agents. They're trying to do something, they have some objective function that you give them, and they can accomplish that function, and in the process of accomplishing that function, they act like humans. This is kind of like a timeline, and I won't hit all aspects of it. I'll just hit a couple of things here. If you look at the early 1940s, the idea of modeling a neuron in a brain, that was kind of like the start in terms of networks. And if you fast forward to now, machines and human beings from a architecture capacity have kind of around the same capabilities. If you think of like a neuron in the brain and a transistor in the circuit, both of them are kind of getting to the order of about 10 to the 10. So in terms of computing capacity, pure computing capacity, you're kind of there. And then there's a Turing test, which was a test to show you put a person in a room, and he has a conversation with somebody on the other side, and he can't tell if it's a machine or a human being. So that was the classic test for AI. And you can do that now. I don't know about the quality of the conversation, but you kind of are there now. And then some other points I would touch upon is kind of like the AI winter in the 90s. I told you about when it was not, you didn't want to say you worked in AI, 80s, 90s, but I mean, that's obviously changed now. Resurgence in the late 70s and through now in terms of statistical approaches. And then a couple of really cool landmarks along the way is when Gary Kasparov was beaten by Deep Blue. And that was computational power, right? Here was a machine which could do 200 million moves, or think through 200 million moves in a second. And in spite of that, it took some time for machines to get to the point where they could beat him. And then AlphaGo, Google's AlphaGo, that helped beat a human being in Go. And that was considered a major landmark in the progress of AI. And then very recently, Google announced its AI first strategy. And there's some nice things about it, right? So we often think of, when we work with a computer, we are trying to understand the computer. And one of the tenets of this was, can the computer understand us? Can you have more intuitive ways of communicating with the computer, speech and so on? Can it understand us? That's one aspect of it. Another aspect of it is just context awareness. I mean, your cell phones are a little bit aware of context in terms of where you are, but much deeper degree of context awareness. And then something that's constantly learning, that's improving and learning over time. So that's kind of like the AI first strategy. you have a set of questions in the left-hand side in terms of what can AI do now. Can it safely drive across a mountainous road? You have examples of what Google was able to do with Google Car, right? Perform a surgical operation, not quite yet. You could kind of do remote surgery, but the actual decision making and doing the surgery itself, making the decisions is still the purview of a surgeon. Converse successfully with another person for an hour. This is the point I made earlier. You have machines now that can converse with you for an hour, but it depends on the quality of the conversation and what you expect to hear there. Discover and prove a new mathematical theorem. This is happening now. You could give it a set of rules, a set of axioms. It'll go off and prove a theorem for you. Play a decent game of Jeopardy. We all know how that worked out. So the other thing I kind of wanted to do on this chart is if you take AI and kind of try to look at the different broad areas. I won't go into the technical details, but if you look at the broad areas, you can think of search and planning. Bissell made the point about actions. So, a simple example would be like you're in a maze and you're trying to find your way out. What actions do you take to get to that end goal? Or you're playing a game of Sudoku and you have constraints on the numbers. And so how do you kind of operate within those constraints? So that's kind of like one branch in terms of search and planning. The other branch is probabilistic reasoning. You have some model of the world, right? So you think like if you have a certain disease, you have some symptoms. So you have some model of the world, and then you want to go off and do inferencing on the model. So you're trying to invert that and say, if you have some symptoms, what is the probability that you have the disease? That's kind of the second broad area of probabilistic inference and reasoning. And the third area is machine learning, where really the big advance has been like, till 2012, you have an image, you have pixels on an image. How do you actually get the computer to recognize what those pixels are? And before 2012, you would have like lots of PhD theses that came out where they would say like, oh, I'm going to look at these pixels, I'm going to come up with some features of my own, and based on those features, I'm going to try to recognize the image. And what deep learning did in 2012 was like, hey, no, you don't have to go off and do the features. The data will build the model for you. So you go off and just look at the data, and you have these neural networks, which are like, you have these entities with like very deep layers, and that can automatically look through your pixels, and from the pixel, kind of map it to what kind of object that you want for recognition. So that was kind of the big advance in 2012, which changed kind of a revolution in the area of image recognition and classification. So this is kind of like a broad overview. Again, I just kind of wanted to give you an overview of the timeline, and then what can it do, what it can do, and then kind of like technically those are three broad areas that you can think of as how AI is organized. Some applications, right? So the whole thing, I made the point earlier with machine learning and vision. Now you're at a point, but that's like a stereo image. You can see the image in the top left-hand corner, and then you can see how using stereo vision, you can detect the edges, you can detect different elements of that image, you can do object recognition and so on. So that's the vision. That's some work that was done at MIT in stereo vision and recognition. And you can kind of see how this could be useful in a factory situation, right? You have an autonomous ground vehicle, for instance, and you're trying to automate some aspects. And the importance of being able to recognize and understand the image. Self-driving cars, this kind of got kicked off, I think it was 2007 when DARPA had something called the Grand Challenge, where in the desert they had a vehicle that had to autonomously navigate, start at a point and navigate a certain terrain and successfully avoiding collisions, taking inputs on what the plan is and so on. And then if you look at the history of what Google has done over the past 10 years to the point where, different levels of autonomy, going through different levels of autonomy and kind of going from an environment like what they did in Grand Challenge to an urban environment. We're traveling at 20, 25 miles per hour, and can you still navigate it? Can you still plan? Can you still recognize images and so on? And a lot of this thing about self-driving cars are like, where am I? Where do I want to go? What's around me? Things of that nature. Kind of the same things we humans think about sometimes. So. And then you look at natural language processing, the Jeopardy, and what Watson was able to do. And that's like, you go to Google, you type in the keywords, you search, you get a set of links. But now can you add context to that links in terms of what you want out of that information? Can it recognize, can it take your questions and kind of parse it out and recognize the concepts that you're trying to communicate, and then organize information and answer that. So this whole notion of natural language processing. And then logic, of course, like the point I made earlier about you're at a point where it can solve theorem proving and so on. So this is all a really good perspective of some examples. What we really want AI to do, of course, is fold our laundry. I have young kids. I have a 3-year-old, and when you do laundry for 3 years old, it is extremely frustrating because there's a lot of clothes. You put in a lot of work, and the pile is really small. So, and there was a really good video at Berkeley about how they have a system that can go off and fold your laundry, and the guy played it at 20 times the speed at which the machine was working, and it took like something like half an hour still to fold that little piece of cloth. So there's some ways off, but that would be really cool. It's just in laundry. I just kind of wanted to. I gave you the different broad areas of AI, and I just thought I'd give you a couple of examples. One is used a lot in Boeing in areas like predictive maintenance and diagnostics. When I told you about the 3 broad areas of AI, I talked about probabilistic reasoning, and I gave you that example of the disease and the symptoms. So we use it, for example, in diagnostics. So there's a military transport aircraft. That's a hydraulic system on the military transport aircraft. And when you do troubleshooting, you typically have these things on the left. You have a sequence of tests, which are the red nodes, and a sequence of components, which are in yellow. And something breaks, you get a fault code, you're trying to troubleshoot, you're going through these fault isolation manuals, and you're running these tests, and depending on what the tests tell you, you can figure out what the problem is. So that's kind of like the procedure. And to the right is kind of like without going again into too much into the technical details, it's a probabilistic inference model of the same sequence of steps. So now what you say is like, you have a fault code, the yellow nodes are still the tests, and the red nodes are the yellow nodes are the components, and the red nodes are the tests. But now, with information about prior history about how these things fail, you know what to prioritize. So if you know that a particular component is failing often, you do that test first, and you can do a lot in terms of optimizing the time you take for maintenance and get better insights in terms of troubleshooting using this. And this is something we did on like I said, on a military transport aircraft program, and it's part of the maintenance procedure there. The other thing is industrial control system security. So you folks are familiar with Stuxnet. I mean, you have a point now where you're at the confluence of IT systems and operational technology. The machines are kind of getting more and more integrated with the IT network, and how do you ensure security there? And that's another great example where you could have machine learning. This was just Stuxnet, as you know. This was like what was used to destroy the centrifuges in Iran, and it was a very targeted attack. It was like down to, in cybersecurity, you try to get something called zero-day exploits, which is something that nobody has seen, and there's a market for these. Stuxnet had 4 of these zero-day exploits. It actually is able to steal certificates and prove that the software was what it said it was. Very targeted. It would stay on a Siemens machine and then control these centrifuges, but it would do that only in a very specific configuration. You had to have like something like 984 centrifuges or something. Very targeted attack, but you were at a point where you were able to get into the system, do these attacks, get the centrifuges to spin really fast, out of control, and destroy the system. And I was at a meeting at RSA last year, and we had the CTO of RSA talk about machine learning. Everything about that conference was about machine learning. It was amazing about the amount of machine learning. He was talking about how when he was a researcher and he was looking through his data, there was anomaly detection. You could do some things in machine learning and clustering of data, and they could kind of start seeing that something was funny, but they didn't know what it was. And then eventually that turned out to be Stuxnet. So it was just a fascinating story. So this is my get off the scene chart. I just kind of wanted to frame it in the context of manufacturing, the physical machines and robots. I talked about the autonomous ground vehicles and so on. We have some of those in our plants at Boeing. Sensing, vision, navigation, really huge advances in machine learning. The third arm of what I talked about in terms of recognizing the world, taking pixels and making it into objects, and then recognizing that and being able to navigate that and so on. Localization, knowing where you are. Monitoring and control, I talked about the maintenance applications, Bayesian networks, a lot of work in analyzing data, machine learning for predictive maintenance. Boeing has a product called Airplane Health Management, and it's a service that's offered to the airlines. But basically, the airplane is telling you ahead of time that something is going to be broken. And so when the plane lands, you have your maintenance ready to go off and fix it. And that's operationalized now. It's not technology. It's operationalized now. I was tempted to have a poke at you and say you could copy us on that, but that's okay. Manufacturing operations management and enterprise system, kind of going up the food chain into more insights into the data, like at the enterprise level. So, with that, I'll stop and.
So let's see. Thank you, Dr. Greaves, and thanks Bala and Bissell for such a beautiful setup to the topic we are discussing. It's great to be part of such a like-minded panel because Bissell talked about importance of ROI. Bala talked about such lovely examples of practical applications of AI. And I'm just going to underscore that further with basically my talk about making AI real, right? So let me start with a small story. And it's funny, like every journey starts with a car. And this is a story about me traveling first time to the US. That was in 1998. Landed from India into San Francisco airport. And I was told that the best way to get around in US is to have a car. So my company, very nicely booked a rental car for me. So I went into San Francisco airport, rental car center, picked up a car. They gave me a one-page map of the Bay Area. With a smile on my face, I took the car out. And as soon as I was out on the freeway, that's when it struck me. That one single line shown on the one-page map is not actually just one road, but there are many that go one over the other. They turn in all directions. And to go from San Francisco Airport to Cupertino would probably take me, 15 wrong turns and tens of drivers honking behind and getting angry. And finally, I did the most sensible thing that I could. I just took an exit, went into a gas station, put a coin in a phone and called a friend. The friend came, good guy, I still thank him. He came, sat next to me, took that one-page map and gave me turn-by-turn instructions. And that is what gets you thinking, right? Why can't there be a friend like always present who provides you those turn-by-turn instructions? And that was 98. You fast forward 20 years. I think we've already gone past that stage of GPSs and turn-by-turn instructions. Today, when in the morning I open my phone, sometimes I get that kind of a message. I haven't put anything in, but it says, well, traffic is normal. It's 34 minutes to Infosys office. It automatically knows my patterns of travel and just suggests that perhaps you are getting ready to go to office now and it would be 34 minutes before you reach there. And that's AI in our daily lives. That's how, and like you talked about, does the computer understand us, right? And that's how AI has started understanding us. But think about it. This is AI in our daily lives, but what about the enterprise, our work lives? Why can't be AI in the same manner useful and consumable in our work lives in the enterprise in an equally simple manner with an ROI that is getting produced today for our today's challenges? And that's what I'm passionate about. I've spent 20 years in the industry basically working at various waves of technology innovation, but always trying to marry it with, if there is a technology out there, how does it solve my enterprise problem today for a benefit that can be put on the books today? So, sorry. Yeah. So just a little bit about Infosys. We are a next generation technology services company with over $10 billion in revenue. We have over 200,000 engineers who serve 1,000+ clients across 45 different countries. And extremely proud to be here because 5 out of the top 10 aerospace companies have called us their partners. And what we do for them is essentially help in designing the next generation aircrafts, transforming manufacturing and supply chain processes, building new age solutions for both aftermarkets and mid-market segments, but above all, helping them achieve excellence across the value chain by using the digital thread. And that, as you've heard earlier, has been a key part of this industrial revolution 4.0 and artificial intelligence as we know it. So is it really time to AI? Well, I mean, there is a lot of data getting collected out there. So with a lot of robotics and machines, well, you could be learning about angular momentum or inertia. But in real world, and these are some Gartner statistics, there are going to be about 20 billion connected devices by 2020. It's 20 billion connected devices producing data on an everyday basis. And that basically translates to about 163 zettabytes of data. That's so many zeros that I don't even try to count them. But that's a lot of data. That's actually more data produced every day than was produced in the last 10 years, taken together. But what does all that data do? We did a small study to understand the AI adoption index across industries, and we've done this study progressively each year. And what we found was that compared to last year, where the manufacturing aerospace industry kind of a feedback was at about 25% adoption, it has increased to almost 50% adoption. That means the data is being utilized, that companies are getting ready to do more and more productive stuff with the AI technologies, and that it's no longer just a talk of an experimentation and a POC done in a back room somewhere, but it's actually getting implemented. Yet there are challenges and there are barriers, because of which it's only 50%, and those need to be overcome. And these point towards availability of talent, readiness of the organization, maturity, and so on and so forth, some of which have been touched upon earlier. To augment that, we also did, and this is a last year study, where we looked at what is an IoT maturity index. And if some of you attended Dr. Ravi's talk yesterday, he explained it in significant detail. But I'll make it short by saying that what we realized after doing this maturity curve, that organizations go through a sequential maturity of understanding their data, adopting it, using it to realize value, and that sequential steps go from obtaining visibility to transparency to using the data to become predictable and hence get predictability, and then only use it for expert or AI-based systems to actually get adaptability, meaning self-healing, self-help, and automated outcomes kind of a solution. Organizations that have not gone through the curve do face and will face the same kind of challenges. As my esteemed panelists earlier talked about, data is a mess. There are lots of data scientists trying to figure something out, but they don't know what. And then I know that there is technology in place that could have achieved something for me, but I'm not seeing it. And that's the traversing through the maturity curve which gets you there. See, we look at it differently. I think a lot has been talked about data is the new oil. Well, if that is true, then the industry that we're talking about, the aerospace industry, has a lot of crude oil. Because of, thanks to the regulation, thanks to the extensive research that goes into producing the final end product, the amount of data that is collected across the aerospace value chain is immense. You have all sorts of data. You have the product data, you've got the engineering and integration data, you've got operational metrics, you've got quality assurance data, and in all shapes and forms. You have it as time series, you've got the images, you've got test cases and test results documented, you've got all the regulatory filings, immense amount of data available. And not only that, of course, there are lots of AI techniques out there. The likes of Google have made a bunch of those open source. There is just, you choose what you want to use. You could be using artificial neural networks, you could be using deep learning, reinforcement learning, what have you. But do we really think just having the data and understanding that there are techniques out there will result in making AI real? No, you need to marry it along with the business outcomes. You need to know why you want to use a certain kind of data married with a certain technique to achieve an outcome. Whether you are going towards reducing risk or improving efficiency. Are you increasing safety or increasing value in a certain case? It's only with a proper understanding of what ROI you're trying to drive that you would be able to bring it to the right kind of data, used with the right techniques to produce an ROI today. And that's what makes AI real. So I'll give you a few examples. This is the work we do, and these are some of real examples all across the product value chain. Examples as simple as putting a chatbot or a natural language processing interface onto operation manuals, making the robotic engine ingest all the operation manuals, and enabling it to help the maintenance engineers in real time with the queries that they have. Now, we all know in the aerospace world, an operations engineer or a maintenance engineer goes through thousands of hours of training, and yet at the time that he or she is supposed to do some work, has to refer to significant number of manuals to understand the actual model, the configurations of the machine, of the aircraft that he is dealing with. And that's significant number of hours wasted. Putting a simple natural language processing interface, allowing the maintenance engineer to query in real time as to what the challenge is, what is the configuration, what exactly needs to be done, immediately saves a significant number of working hours for each of those operations, whether it's for airlines, whether it's for MROs or the OEMs themselves. Take another example, just taking time series data, and this we did for an aircraft landing gear, taking time series data from the number of sensors available on landing gear, marrying it together with the asset maintenance records, and also the performance analysis that is coming through to predict the remaining useful life. And what that enables you to do is you're able to predict and schedule the maintenance as they are required, and you're able to avoid flight on ground situations. Now, FOGs are the biggest revenue loss causes for airlines. And here is a practical example of how OEMs, MROs, and airlines all are taking advantage of that predictive analysis to save money today. And then we can take more intricate and more esoteric cases. This is where we have tried to do engine balancing using AI algorithms. Now, for those of you who know, I don't need to explain, engine balancing is a very, very critical aspect of making an aircraft flying ready. And engines are very unique. I mean, despite being fairly standard, but each engine is unique, and you need to actually carry out multiple test flights to understand the weight variance and progressively bring the variance down. It takes a number of test flights, a ton of data to be collected. Now, while this problem cannot be completely eradicated or solved, you cannot stop doing test flights because engines being unique, you don't have enough historical data that will provide a prediction. But you can use AI algorithms to learn and narrow down the variance in a significantly lesser number of test flights. And then there are significant other examples around product definition engineering, use of knowledge-based engineering, or manufacturing and shop floor integration with predictive maintenance. These are all examples of actual ROI being achieved today in the product lifecycle area. But why only product lifecycle? We are all large enterprises running a business, and if we stretch our imagination a bit, there are significant number of use cases on the enterprise side. Take finance, for example, applying a machine learning algorithm to forward simulate a journal entry which is made today to look at what errors it might have on the day of closing, and then being able to take a smart assist bot to tell the entry operator to say, hey, by the way, there is a mistake in this entry. It will get stuck at the time of month-end close. So do you want to change it? You are proactively preventing a month-end close from taking 10 days and multiple adjustment entries to happen automatically. Aftermarkets has been a huge area of focus for us. It's one area, especially in aerospace, highly unpredictable because the demand for aftermarket parts and services is dependent on the actual situation, whether it's a flight on ground situation or something has gone wrong. How do you predict that demand? There's no analytical, definitive mechanism of predicting it. But through machine learning, looking at patterns over time and over a long period of time, and marrying it with actual aircraft maintenance data and its flight schedules, we can increase that prediction accuracy by almost 20 to 25%. And that helps in planning for supply chain, for having the right parts at the right places. And then on the extreme right of the slide, you will see some examples around health and safety or future of training and education using augmented reality, using virtual reality, and so on and so forth. Especially when you think of the changing nature of your workforce, working with more millennials and Gen Ys, these are the things that are needed to make an organization more productive. So in short, I think when we look at across the value chain, not just the manufacturing operations and the 4 towers of efficiency within manufacturing, whether it's maintenance efficiency, operations efficiency, information or energy efficiency, but across the enterprise, including in engineering, supply chain, and other services, I think there are enough practical applications of AI today that can produce immediate ROI, results that speak in dollars. And I think the call to action to all of us is to ensure that when we look at the use of technology and the underlying data, we also think about the use case, the value you want to drive from it, the organization maturity that goes with it, and the learning and training that the employees need in order to be able to use it. But it is not just a shiny object with a promise of the future. This is actually real today, to be used today by all of us to make a real bottom line difference on our books. So that's what I wanted to say. I'll hand over to Mike. Thank you.
Thank you, Nitin. So we have a lot of questions, so I would encourage you to go to slido.com and put in 8018 and vote on the questions, because we won't be able to cover them all. But we have a number of them, and I'd like to sort of start off our panel with sort of a very practical one. But what do you think are good practical examples of AI, and where do you think it'll help industry?
Okay. I think we see today 3 main fields where we've seen it work, and here the panelists, we all spoke about this before. If you categorize them roughly, we see them around quality, identifying quality issues in real time often, or certainly earlier in the process. Second scenario we spoke about is predictive maintenance. Again, when is a machine or tool or anything like that is up for maintenance. And the third area is actually around the process optimization. If today we're talking about manufacturing and perhaps as opposed to the financial processes, so we have a process to manage. Can we manage it better? Can we manage it more optimally? I think so. What we also see, and again, it's our experience, is that the latter one also constitutes, let's call it the full business workflow we saw before. So if you think about a quality analysis, it's more of a transactional problem. I look at a picture or an image or an analysis from ultrasound, I identify I have a problem. How you fix it, who does something about it, that's not my problem as the quality AI module. So that's a transactional problem. But if you take it all the way to the extreme of, let's say, process optimization, you see the complete workflow. You see, first of all, where am I? Context recognition. Where is this going? And then what do I do about it? That's the action also Bissell had mentioned. So here you see the complete business workflow. And the more you're able to produce that complete workflow, well, it gets harder to do, but you also generate more value. If you go to a doctor's appointment, there's diagnosis, prognosis, and treatment. And you want to see all 3 of them. And I share here the different perspectives. This is already happening, and we see these examples more and more. But roughly speaking, I would look at these 3 categories, the latter one being typically the most comprehensive.
Paula?
Just a comment to add to what Avner said is, if you look at machine learning, for example, there was really an interesting example supporting what you were saying in terms of quality control. There's this guy who's kind of like a preeminent researcher in AI, and he recently started this company. And the focus of that company is live metrology. Can you actually look at the process or the manufacturing process as it's evolving, and using imagery, can you ensure quality control? So it was just a good example of.
And Mike, if I may add, I think as AI is coming out of the POC mode and needs to get more into production, the kind of use cases that we see taking precedence would be those that directly have a top-line impact, meaning enhancing revenues or creating new opportunities of revenues, versus those which are purely cost reduction or efficiency based. However, there are applications in quality and health and safety which will always take precedence because the industry itself is built on extremely strict standards around quality, health, and safety. So, and I think there are enough examples of the use cases, the way they're spanning out.
So from my perspective, I don't know that I would add much more than what was initially said. Clearly, quality is an area. I think the thing you have to ask yourself is, and always ask this question is, where are we seeing returns that are positive in the use of this capability today, and then where can I apply that within my company? And so predictive maintenance, quality are clearly the areas that have the highest and quickest return in this area. But I also believe, and from having managed a lot of this activity for the past 30 years, that we see an enormous amount of attrition of our knowledge leaving. We've been talking about it for 20 years, trying to prepare for it for at least 10 years, and we're doing a lousy job of it. And I do believe that this capability and technology is an area where we can equip as aids in the transactional process, and I don't care whether you're talking about finance, procurement, manufacturing, the knowledge that's embedded in people today to help the folks make faster and higher quality decisions up front without having to have overly sophisticated knowledge sharing activities, because they aren't really working. We're seeing gaps today in our business where we've lost key skills and capabilities in people, and this is an area where I do believe we can recover from that.
Thanks. So the next question is, how do we have visibility in what AIs are learning and what behaviors they change? So this is the black box question that is, highly problematic for AI if we basically, start to let AI take control, and then where are we at? So how do we have visibility into what AIs are doing and what they're changing, as what we have set up?
I think, the AI as a black box is concerned. People, it's a question of trust. And I would say, like any relationship, so this relationship between AI and us, it takes time to build. People need to understand, to an extent, how it works. I think one of the problems and challenges of machine learning as one of many AI techniques is the fact that it's in many ways a black box. Sometimes even the data scientists don't even know how it worked, but it did. In this respect, building of trust, I think, also calls for domain expertise. I think we all spoke about this before. It's not just the expertise in the data sciences and the mathematics of AI, it's also the problems you're solving. AI for manufacturing as opposed to AI for pharmaceutical treatment. So once the user understands there is the domain expertise behind, it helps. But at the end of the day, if it works as a measure of did it help me as a user, as a consumer of the technology, is very important. Is it making my life easier? Is it bringing value? And the one thing that really throws back this relationship is what we call the glaring mistake. The obviously, pardon the language, the obvious stupid recommendation or decision that the computer made. So in that case, I guess like any relationship, it takes trust back a few miles, and then you need to rebuild it again. So perhaps as opposed to measuring what the AI did, we should measure the outcome and see if it's bringing value.
And I think from my perspective, again, technically, I do not know if there is a way to really determine what AI is learning. But as responsible industry leaders and users of AI, we need to understand that AI will learn from the data we feed it. And having a better understanding and classification of the data we are providing, and at the very least, basically being able to differentiate between private, sensitive, or otherwise business data is absolutely important, because those are the only guardrails you can actually provide to an AI to kind of limit or restrict in a fashion of what it learns.
Yeah, I think the learning is it's an open problem. How do you trust an AI system? In machine learning, there's some techniques where you can look at the data and kind of break it down into your data you train on and data you test on and data you haven't seen at all. So that's kind of one technique. But it is a big problem. I think it's an open problem. If you look at Microsoft, right, they released this chatbot called Tay, which is going to be learning from different people and then being able to chat based on that. And I think within 24 hours, people were training it to do things that were not very nice. It will go off and do racist statements and all that kind of stuff. 24 hours. So you can teach the system anything, right? So that is a risk. And the final perspective, as I said, I think this is a very open problem, because DARPA actually had a recent effort into what is called explainable AI. How do you know what AI? How do you explain how it came up with that conclusions?
So I don't believe, and I talked about this, skill-wise, we're quite ready for a lot of usage yet until we bring up the capabilities of some employees. You don't need everybody to understand this. You need the people that are implementing it, that are trying to squeeze the value out of it, to really understand it. You think about it in the past with all the big implementations of different software we've done before. It's the individual understands the application, the transaction that's taking effect, the integration between applications, and where the data goes and how the data is being consumed. Now add into that equation, I've got all this mathematical logic and activity that's going on that I've never had to contend with before, because there's almost like another brain in the middle of this helping with the decision-making process. You need enough people coming into your company that are going to be putting this to test in a proof of concept, in a sandbox, in some kind of a test environment where they throw enough variables at it that they're really understanding what's occurring. Because this is not, in my opinion, the kind of technology where you learn after you've deployed, like we do with so many other things. This is something you need to come into it with a good understanding first, so that you can manage the outcome very quickly on deployment. And we fail as companies, mostly in the deployment areas, on almost any technology we bring into the company, because we just don't have a good handle of it completely at the time of deployment.
So there was a question that about culture, and I'm just going to sort of jump to that one, because one of the things I sort of teach in my MBA course is culture eats strategy every day of the week, and so how do you think the acceptance of AI within an organization is going to be, and what do you think the cultural changes are going to happen in terms of acceptance of AI?
I can begin on that. So I think there is a cultural change within organizations which is already happening because of the nature of changing workforce. And as we see the newer colleagues come in, the millennials and the Gen Ys and Gen Zs, they are used to consuming technology on a day-to-day basis for their daily lives. And they do expect to work in their workplace environment also in the same manner, to be able to, instead of having to log on to a PC to do a workflow activity, to be able to have an app on the phone and basically just do what is needed, and for the phone to recognize what they're doing. So I think the cultural change and acceptance would largely come from the kind of human experiences the AI creates, how it is made more consumable and purposeful. And I wouldn't talk too much about it. There's a talk coming up by Shamla, who's talking about some of the purposeful nature. But I think the cultural change is certainly needed. and it's going to be an important catalyst to adoption of AIs within the organization.
Yeah.
I'll add to that. I'll just say, like, when we go to Amazon.com right now, right, and you search for something, and then it makes recommendations for you, right? So that's AI at work. That's collaborative filtering at work, and we accept it as part of our lives. At the other end of the spectrum, you have, like, if Boeing comes and says, like, hey, we have a completely autonomous flight that's going to take you from point A to point B, what would be the culture in terms of accepting something like that? I don't know. I mean, airplanes are 90% autonomous right now, but that other 10%, would you fly? So
I would also argue that, sorry, Bissell, culture is not one word. Culture varies by country, varies by industry. Aerospace culture is very different from automotive, from consumer packaged good, and culture varies by organization. I think we all understand that. So I would urge you to look inside your organization structure and culture and re-answer that question given this input. How is my organizational structure unique, and how do I want to implement AI? And again, put it in the framework of new technology per se.
So change management is kind of the critical component of introducing new capabilities in any kind of company. If you fail there, it doesn't make a difference how good the technology is in a lot of cases. So it's definitely important. I would say that as long as, because as the folks were saying, we're getting more used to AI capability supporting our daily lives. But I would say as long as we are inserting the capabilities in kind of point solutions that are quite successful in the deployment, people will get more used to it. And again, not everybody has to understand it. I read an article the other day that said a pilot today only flies for 7 minutes of a total flight of an aircraft. We're all sit back there and we're just ignorant consumers of the activity going on. I wonder what the hell the pilot's doing up there for the other 3 hours, right? As long as we don't know and we don't care, we don't, it doesn't mind. And I think that's the way most of this is going to happen inside our companies, as long as we're successful with the deployments of this and its point solutions along the way. I think the adoption will come. I think people are getting more and more mentally willing to accept the technology as the decades move on. So I don't know that I see it as much of an issue. It all comes back to the success of the actual implementation and making sure that you're really ready for every single deployment.
So here's an Uber car question: will ethical concerns prevent AI from being the final decision point in the kill chain? We just had an example of that, unfortunately.
So I'll just start with that, because I believe, we're a very complicated business. We have very, if we just talk in the manufacturing area, very expensive things that go on. I don't ever see us ever getting to the point with AI adoption where we're allowing activities to occur that aren't very well controlled. So I don't have as much concern about that. My concern really comes in getting the knowledge of the employee up to the point where they can control the outcome to the business case that they're running after.
I think, today, if the question is about the usage of weapons, yeah, it's an ethical boundary, period. The technology is there for weapon systems to be autonomous, or at least some of them. So I think the specific answer to the question, yes, it's a matter of ethics and culture. Of course, it's a loaded question. We may want to expand that into more mundane questions, and I think Bissell touched upon it. When do you let the software take action as opposed to simply making a recommendation? And I think if we put this, back to business, it's a question of time. Do we have time for the human to intervene? And also a question of cost, or the cost of a mistake on either side. And you need to weigh those. Do you let a software shut down a nuclear reactor? Maybe you should. Do you let the software shut down the factory? Maybe you shouldn't. So it comes down to the cost of a mistake and the time you have to make the decision.
Well, I think it's AI is a learning technology. It learns, and I think learning from mistakes as well as false positives and the reinforcement learning. And I think we as human beings need to learn along with it because we need to learn how to use it. We need to learn how to control it. And end of the day, we are responsible for programming it, setting it up, and we are responsible for using it. So I think I don't see a point where it becomes a kill switch question. It's always going to be about an adoption curve and being responsible about using it.
I think the point I would make in the kill chain is, what if your adversary is going to use AI against you, right? Then what are you going to do? Are you going to go, get into that whole back and forth, right?
Yeah.
And so I think it's comes down to what are the rules of engagement? I mean, we have rules of engagement in war today. What would the rules of engagement be as we start using AI in our weapon systems? And maybe you go back to science fiction, right? What was the 3 rules of robotics that Asimov said? He said the robot should do no harm or to a human or through inaction cause harm to a human, will obey all orders provided it does not conflict with the first, and so on. So you get the idea. So, yeah.
But the issue, I mean, let's sort of flip that. So the issue is, what if our adversaries are doing it?
Yeah.
I mean, now what do we do with AI, and do we have an obligation in terms of something that we do with AI that sort of prevents that?
I urge everyone to read a book from the 60s on science fiction. It's called Colossus. It's where if the Soviets and the Americans this is Cold War, they happen to build an AI machine to control ballistic missiles, and coincidentally both machines come alive together and then take over the world. So I hope we're not there.
I'm less concerned about that than bad actors, humans who are controlling that colossus.
Yeah. Just one other point I wanted to make, right? So you hear Elon Musk talking about, AI is an existential threat to humanity and so on, right? So I mean, I almost look at that question and flip it and say this is a little bit far out, and I may be rambling here, but what if the machines have an ethical thing about whether they want to get rid of the humans, right? So that's something to think about as well. So, and he's putting his money where his mouth is. I mean, he started this something called it's a company doing research in AI with the corollary of make sure that it's safe. It's not going to be a mad rush on the corporate side, but this is a non-profit to make sure that whatever advancements you have in AI come with some safety guards.
So the next question is, what do you think are good practical examples of AI, and where do you think it'll help industry?
Yeah, we went through that.
Yeah.
Oh, we did? Sorry.
Yeah.
I thought it was a variation of it. I don't know why it didn't go away. So if DoD doesn't trust modeling and simulation, how will they ever embrace AI?
My experience so far is that there is a relatively high amount of initial trust. And like the product example, I really believe we're only going to allow incremental control to grow. Once we've gotten things fully proved out, we really have thrown enough variables at it, we understand where it's going to go, and that doesn't make a difference whether you're putting it into the business or the product. But I think from a customer standpoint, they embrace this enough that they're throwing money at it, from CRAD money, and I believe that there is an embracement there as long as we mature the capabilities and we bring them forward for them. But they're putting money into it, so I don't know that I see too many trust issues.
Anyone else?
We see it as any technology adoption. Maybe it's more exotic, or maybe it's not. But if it brings value, if it works, and certainly the question of incremental changes. It's very popular to talk about, Terminator and machines taking over the world, but at the end of the day, we're talking about very specific tasks that the software is doing. And then it's a question, is it doing it better, or at least as good, but automated than we are?
So looking at digital manufacturing, what are the key challenges experienced by companies adopting that?
So in our world, and this has a lot to do with possibly, maybe our culture with things, but a lot of our components in the manufacturing area aren't as connected as one would imagine. And we have a lot of the supply chain involved in managing it for us and on our behalf. I think one of the challenges that we have as we build out that digital capability is bringing a lot of things that we outsourced back in-house and managing it ourselves. And so I view that as one of the challenges because we've outsourced, I'll give you just simple machine coding to suppliers like KUKA and those types of folks. And so, for us to really harness this digital environment, we got to bring all that back in-house. I see that as one of our challenges.
When we look at companies adopting digital manufacturing, I think it goes back to the challenges that we talked about earlier. Understanding what data you have, how you're going to use it, and then preparing the organization's maturity to be able to use it, understanding and getting visibility into the performance first, putting the KPIs right, and then progressing from there to transparency and visibility stages, transparency and predictability stages. And using that not for an academic exercise to determine, oh, now I can report 2 more things. It's about what change you want to bring with it, because if it does not approach it with an ROI perspective, then eventually it dies out.
We see a lot of companies that somewhat get lost in the journey, and I think it's important to understand that this is a journey. And a lot of good companies like Infosys serve as a guide in this journey. But at the end of the day, what is it that you're trying to do? If you're not able to answer that question, don't even start. And people jump into the deep end of the pool and then try to figure out how to swim. It's the other way around. What is the problem? What is the business problem you're trying to solve? Okay, good. Is it valuable? Excellent. And then the question is, how do I solve it? And for that matter, is digital manufacturing or AI the right tool to do so? So start from the end and go back. That typically works, at least for that first few steps of that digital journey, until you have a good sense of what works for your company.
So this is kind of like a related issue in terms of how we are, in terms of factory automation, right? We have increasing amount of sensing, gateways and processing and trying to get applications out of that. And so this whole the Internet of Things as it relates to manufacturing. I think one of the big challenges to widespread adoption is like a lot of it is very vertically integrated. You'll have like sensors, a gateway technology. There's a whole alphabet soup of how you get your information to your gateway. You have a gateway technology and so on. So a lot of them are vertically integrated. So as things kind of fall into place, the development of standards, so you can kind of talk across these different applications. How can you share data and talk across these different applications and the synergies that it could provide you in the digital manufacturing area?
So related to this, where's a good starting point? I mean, for the people who are out there that aren't, no AI, barely can spell IoT, what's a good starting point? How do you start this? I mean, what's the recommendation for getting going with this so that you can start to make some progress?
The simple truth is we see a lot of opportunity, and I'll explain where it's coming from. So I would obviously go for the low-hanging fruit. You want an early win to gain confidence of management, to gain confidence of the people on the production floor. And the abundance of opportunity comes with this surge of data on the one hand. By the way, some of it existed forever in ERP and PLM. We just never knew what to do with it. More data is coming from sensors. And on the other hand, computing power is a no-brainer. So the opportunities exist. Again, what is the problem or problems that you're trying to solve? And literally pick the low-hanging fruit. Don't go for the toughest nut. That typically spells trouble. And if you look into it and you look for opportunities methodically, you'll simply find, if it's manufacturing, you'll find manufacturing challenges. whether it's predictive maintenance, material optimization, supply chain, whatever it is, work back from there.
I'll probably just give an example, repeat an example of what Dr. Ravi presented yesterday. If you're looking at manufacturing process, you want to pick up a low-hanging fruit, something which is a problem area and hence will have a straight line to ROI. He used an example of predictive maintenance of an autoclave yesterday. In a manufacturing process, of course, autoclave ends up being a very critical step of the entire process. And typically, these are very old machines. They've been put in place decades earlier. Instrumenting it in the right manner, getting the right data out of it, being able to predict 25 hours in advance when a potential failure to an autoclave can happen will save real production dollars for the shop floor management. And it's a great proving ground for what data can do using artificial intelligence.
I mean, I echo what he said, right? What he said in terms of starting simple, starting with something that you have a clean value proposition for, and then not getting lost in all the hundreds of models and technologies that AI has, right? I mean, it's just every day you hear about something, and it's complex. Start with something simple. If you look at probably the AI technique that's most widely used commercially now, it's simple classification. You look at things and you're trying to break it into different classes. So start with something simple, established, where there's a very clear value proposition, and then go from there.
So I don't believe that you chase AI and look for AI initiatives as much as you're chasing initiatives in the company that you're trying to improve efficiency, improve quality, you're trying to get some return on things. And so I think what ends up happening is you discover AI capabilities that are already out there and embedded in certain things that you're purchasing that you can make better utility of. So I'll give a small example. Today, most of us, we hire people, right? And we have usually a vetted process internally where some HR person takes a role and responsibility to try to vet those employees for you that are coming across in the tens of thousands of resumes that come in for a job today. They don't do a very good job. I know internally myself, most of the time I tell HR, please let me do all the screening, because they'll screen out people that are high quality people, and that happens because of human error. It happens because of lack of really understanding the requirements. AI today in the area of resourcing is doing a lot of that much more effectively than the actual HR employee. And so the business case is, I got to hire a lot of people. I don't have time to look at all the resumes. I go look for a capability, and I find an AI embedded capability in there I can harness and make good use out of. And I think that's really the way we're going to pull this in to every business process within the company.
So there's the question here about sort of the connection with universities. What role do you think universities can play in assisting you in terms of moving to this kind of area? I mean, is it hiring? Is it funding research with them? Where do you think universities' role is in this?
I just having put 3 kids through engineering school, I'm often at times excited about what it is that they're learning and dismayed in other areas, and dismayed in the areas of practical application. I have a daughter just starting on the F-35 at Lockheed as an engineer, and she comes back and asks me a question. It's like, oh my God, how did you go through 6 years with a graduate degree in engineering and didn't know that, right? Because they get so wrapped up in book learning and not practical experience. And so, I love that part of the whole learning experience. And, as we work with you in the Florida Institute, we're finding that the integration of the university into the business environment is now starting to kind of knock out all of those problems, right? It's really exposure into each of our worlds and then allowing that exposure to bleed into the student body. But I can think of just again, having put 3 kids through engineering school, I can tell you that I could come up with all kinds of areas of opportunity in the university environment, because even the internships don't don't cut it all, because we as companies don't do a good job of exposing them to all the things they need to really understand. So it's really just building and maturing that integration.
I think from our perspective, since we work with a lot of cutting edge of technology, working with customers on their latest and greatest problems, what we've seen is that universities play actually a 360-degree role in how we collaborate and work with them. On one hand, it is about obviously preparing the talent, so getting them the right exposure, right education, like Bissell touched on it. But I think there's equally important role, and we do partner with universities in doing research projects, doing joint innovation programs together with our clients, the academia, and getting the startup ecosystem together. Because we believe some of the solutions that we are trying to find are problems that are yet not fully defined or problems of the future. And some of that requires a complete greenfield thinking, where we need to bring all these constituents together to make it happen. And again, going a little further back and taking it slightly away from the question, I think also to emphasize on the K-12 education of bringing STEM and importance of computational sciences into the grassroots of learning across the system, so that our talent of the future is better prepared for these challenges.
Anything else?
One thing I would add is that at Boeing we have a kind of like a university strategy. So we have a dozen schools in the US which we say are like focus schools for particular areas. There's one for manufacturing. We work very closely with Georgia Tech in manufacturing. And then we have similarly centers around the world, like Singapore Institute and so on. So we have specific schools for manufacturing. And in addition to what the previous panelists did, one thing we try to do is we try to have these rotation programs. So we have somebody from a university, a college professor, come in and spend like 6 months or a year to Boeing on some kind of a fellowship program. So he kind of really gets a first-hand understanding of what the challenges are out in the factory, and then takes that knowledge back and then kind of works with us after that to try to define some of these fundamental research problems that they can help us with.
Great. Well, we have a lot more questions, although they've disappeared, but we've run out of time. So help me thank our panelists for just a great session here.